Welcome back, everyone. In this video, we're going to start writing our chunk function, and essentially we're going to start doing exactly what we did in the Google Colab notebooks. Okay? So over here, let's define a function that will do everything for us. It will chunk up all the samples into length of 2048 tokens. So I'm going to create a function, and it's going to take in a sample parameter, and it's also going to take in a chunk underscore length, which is going to be 2048. Now, over here, what I want to do is first let's write the function, and then let's discuss it. But keep in mind, it's going to look almost identical to what we've looked at in the Google Colab notebooks. Okay? Keep in mind, this is what a sample is. And we're going to define, how many samples we send in. So don't worry about that. For now, let's just create this function. So over here, there is something that we have to do. And that actually, I'll put it on a new line. Global and remainder. And over here, what we're doing is we want to be able to access the remainder dictionary. Remember this. To put the remainders in, right? We discussed how sometimes we're going to have remainders because we chunk up samples into lengths of 2048 tokens. And in order to be able to access the remainder dictionary, which is defined outside of the scope of this function, we have to use the global keyword. Okay, so that way when we're referring to remainder, it will check that, okay, remainder is defined outside the function and we're going to have access to it. Okay, so that's what the global keyword does. Now, concatenated underscore examples is going to be equal to, and we're going to do exactly what we did in our Google Colab notebook, list, chain, and then we're just going to do sample at k. And then we're going to say for k in sample dot keys. Okay, so remember what this line did for concatenated examples. We can come back over here. And essentially what we're doing is this is how we receive the samples, like so. And once we run it through the concatenated examples and we print it out, we basically stretch out all the samples that we received. In this example, it was 3, and then we make it into one long array using the asterisk, which is, we're expanding the array. We're going one level deep into the array, and then we use the chain iterator along with the list constructor, and then we're just looping over the sample.keys. And remember, the keys are input IDs and the attention mask. Okay, so if that doesn't make sense, please go back to the video because we've talked about this in great detail. Okay, now we have the concatenated examples. Then what we're going to say is we're going to say concatenated examples, and we're going to say that it's going to be equal to, and I'm going to say k remainder, where we're accessing the remainder dictionary. And that's going to be plus concatenated examples at k for k in concatenated examples dot keys. Okay, so what's happening over here? Well, essentially, and I don't know why I'm missing white space. Do we have a linter? Oh, we have a linter set up here. Okay, so remember over here what we're doing is we're essentially checking what's inside the remainder dictionary and we're adding it to the concatenated examples. Okay, so if we come back to our notebook and we scroll down, remember we've talked about this, how in the first round these are the input IDs, we flatten it out, and then we add the remainders, but on the first iteration we're not going to have any remainders. And so that's why it stays the same, as you can see, 1 through 12, 1 through 12. But in this example, we said that the max length is 10. So that means for the next round, we put in 11 and 12 into the remainder dictionary. And then on round 2, we simply access the remainder dictionary like so. Okay? Like we did over here. Okay, so that's essentially what we're doing. We're checking to see if there's anything in the remainder dictionary. If so, we're adding it to our current concatenated examples. Okay? Now I'm going to say that the batch underscore total underscore length is going to be equal to the length of the concat. I do not like how there is so much linting. As you can see, batch total length is assigned but never used. Undefined name concat, because we actually want to use concatenated examples. So we're going to say that the batch total length is the length of the concatenated examples, but we're not done there because we have to access it using the list, and then we say sample.keys, and then once we access sample.keys, we say that we want to access 0. And okay, what happened over here? So over here, essentially what we did is, if we go back, and this is exactly what we did. We did length of concatenated examples, but over here we did add the attention mask. But over here, what we're doing is we're just saying, okay, what is the length of the entire batch? And the 0th element over here, when we look at samples.keys, is input IDs, but we very well could just use 1 over here, which would be the attention masks. So this tells us, okay, in the current batch, once we flattened it out and we've added all these samples from the remainder, how long is it? Okay, so that's all we're doing over here to get the total batch length. Then what we're going to do is we're going to say if batch total length is greater than or equal to the chunk length, and remember, we define chunk length over here. By the way, why is it expected 2 blank lines, found 1? Could it be this? Sorry, I'm just trying to get why the linter is giving us issues, but I'm not sure why. Okay, so now we're going to say if the batch total length, which we just calculated, is greater than the chunk length, which is 2048, then what we're going to have to do is we're going to do batch underscore chunk length is going to be equal to, and we're going to say batch total length, and we do a hard division by the chunk length, and then we multiply that by the chunk underscore length. Okay? Like so. So now, essentially what we're saying is the batch total length is it calculates how many total chunks essentially can we fit, and one chunk must be 2048 length. Okay? So we're essentially trying to say, okay, how many total batches can we have so that it perfectly fits into 2048? So how many of these batches are we going to have that have a length of 2048? And if this doesn't make sense right now, please don't worry about it, because in the coming videos, we're going to be doing a lot of print statements in this chunk function, so you will understand it. But this hard division, what you see in Python, essentially, actually, I'm going to show you. If we say 8 divided by 4, that gives us 2.0, right? But if we say 8 divided by 6, we get 1.3 repeating. If we do a hard division, as you can see, it's 1. So it tells us exactly how many times can it fit total. So let's suppose the batch total length is let's say it's 100. So let's say that's 100. And then the chunk length would be 15. If we do this, we get 6. And now let's multiply this by the chunk length, which is 15. That means we have a total of 100 samples, but only 90 of them can fit perfectly into sizes that we want. And in our case, these sizes are 2048. Okay, so that's what we're doing over here. But again, if that doesn't make sense, we're going to discuss that later. And keep in mind, the remainder that we get from over here is going to go into the remainders dictionary. Okay, so that's what we're going to be doing. And now what I'm going to say is the result is going to be equal to, and we're going to say K, and then we're going to say, I'm sorry, this is going to be a very tricky line. We've discussed this in the Google Colab, but typing it out is tricky. So I'm going to be quiet for a bit and focus on not getting the syntax wrong, okay? Because here is where we're doing the chunking. I from I plus chunk underscore length. And then we're going to say for I in range 0 all the way to batch underscore chunk underscore length. And then it goes to chunk underscore length, like so. And then we're going to say for K and T in concatenated examples dot items. Okay, now let's see what the issue is. Missing white space here and here. No, didn't solve it. Do you want... Okay, I don't understand the linting errors right now. But don't worry, this is going to work just fine. It's underlined with red because of some weird linting that's been set up by default on JupyterLab notebooks, but don't worry about it. Okay, so what is this line doing over here? Well, the result, if we come over here, is actually what we're doing over here. Remember? Here we are chunking up. I mean, not chunking. This is where the slicing starts. Okay, so if we have input IDs that look like this, along with an attention mask that looks like this, after slicing, we slice it into our predefined slice lengths. So over here, the chunk length was equal to 5. So when we slice it up, we go and we create 1, 2, 3, 4, 5. So we create these samples that have a chunk length of 5. Okay, and then we fit in as many as we can, and the remainders are put into the remainder dictionary. Okay, and that's what we're going to be doing over here. We're going to say that the remainder is going to be equal to, and what we're going to say is K and concatenated examples at K, and here we're going to say batch chunk length, like so, and then we're going to say for K in concatenated examples dot keys. So over here, the batch total length, remember we got the batch total length over here, and we got that by looking at how many items are in the chunk essentially. So that's how we get how many samples we have in the batch. And then if it's greater than the chunk length, we update the batch total length to be equal to the number of samples that can perfectly fit our predefined chunk length, which is 2048. And anything after that, as you can see, this is what we do in Python, anything after that, so here we have the colon, we just simply put into the remainder dictionary, okay? And it's the exact same thing that we've did, let's scroll all the way over, where was it? Here, okay? Actually, sorry. So it's what we did over here. So the remainder is going to be all the way from this number, what we could not fit. So over here, this number is 10, and anything that we couldn't fit will just simply go into the remainder dictionary. So that's what we're doing over here, and I misspelled remainder. I'm just going to copy it from over here. So remainder is going to be equal to concatenated what's left. And now what's left to do is we're going to say that the result labels is going to be equal to result input underscore IDs dot copy. So we just copy the entire result that we had from over here, and we're going to add a separate labels key to it, which is going to be identical to the input IDs, okay? But we never want to alter, something. So that's why we first create a copy, and then we say, okay, the labels key is going to be equivalent to the input IDs key. And then we simply say return result. And I know this was a tough function to write, but I hope that by going through it in Google Colab previously, you have a good understanding of it. And if you still don't, please don't worry about it, because we're going to finish this chunking example, and then we're going to be printing out a lot of things over here so you understand what's going on. And I will see you in the next video.